Welcome, friends, to another episode of In Conversation With. My name is Jacob Freydont-Attie. This is the Center for the Arts weekly show where we talk to Nevada County experts on a variety of topics, including lifestyle, nature, food, and art. Today's topic will definitely be nature. We are here with Shane Hanofee from the California Native Plant Society. Welcome, Shane.
Thanks, Jake. Really happy to be here. Thanks for having me.
Thank you. Before we get going, I'm going to tell you what's coming up at the Center for the Arts. On Friday, May 7th, we will be broadcasting live from the center with California singer-songwriter Jessica Malone, who blends soulful lyrics with an organic sound. Her voice, accompanied by soaring violin melodies, guides you across terrain of rootsy folk, rock, jazz, and Americana. Free for members. Public tickets are on sale now at thecenterforthearts.org. Saturday, May 8th is Second Sundays in downtown Grass Valley. It's a great way to shop local and to see what's new. The Garnucci Gallery at the center will be open from 10 a.m. to 4 p.m. This is the last chance to see the current photography exhibit, Remembering a Peaceful Warrior, featuring the photographs of Michael Christopher Black. This show, of course, is free for members. Otherwise, tickets can be purchased at thecenterforthearts.org. And we do encourage everybody to join the center, and then you get access to all the past In Conversations With. Okay, Shane is a self-taught botanist. He is vice president of the Redbud chapter of the California Native Plant Society, also the web editor and chapter council delegate. I assume that's the Nevada County chapter?
Yeah, Redbud covers western Nevada and Placer counties. So
okay.
Nevada and Placer.
Tell us a little bit about yourself, how you came to Nevada County, how you came to your expertise and such.
Sure. Well, I moved out. I'm from the East Coast originally, and I moved to California about 12 or 13 years ago, and initially moved to the Bay Area, and did my thing out there, and eventually, as I think many people have experienced, got priced out and had moved out to the foothills. And when I was here, I just absolutely fell in love with the nature, specifically the plant life. I remember going outside of my little house and just wondering, what is this this tree with these enormous leaves? And to come to find out, it's the big leaf maple. And find this vine. I'm like, what is this carnivorous plant? Well, it was the Dutchman's pipe, which is not a carnivorous plant, but it certainly looks like it. And got tired of just not knowing what all the plants were. And so I purchased myself the Redbud chapter. They put out two field guides, one on wildflowers and one on trees and shrubs. And I just took it upon myself to read those like practically every night. Like it was my bedtime reading. And would go out hiking all the time and try to identify the plants. And, it's been years now, and that has just compounded on itself. And I've just become more obsessed and more immersed and, find myself, really knowing the plants of the Sierra at this point. And got involved with the Redbud chapter about 4 years ago and kind of risen through the ranks and done a whole bunch of different things for them. And now I'm here to introduce you guys to CNPS and to plant life. So, yeah, really excited.
And tell us a little bit more about the California Native Plant Society and what they do exactly.
Sure. So the Native Plant Society, we're one of 35 chapters. It's a statewide organization. And basically our goal is to conserve and teach about native plants and really support plant sciences and give sound scientific principles focus in the plants, because the plants really are like the basis for all of the other life that we have here. All of the insects, the mammals, birds, reptiles, what have you, it all starts with the plant life. They're the base on the web of life. And so the more we understand about the plant life, the more we can extrapolate to these other organisms, the more we can understand biodiversity in its biggest form, in its truest, largest form. And I think plants sort of get overlooked. There's this concept called plant blindness, and it's basically you look out at outside in general, and you just see this big green blur, and it's all the same. It's the woods. You see the forest, but not the trees. To flip that one on its head, And one of our main goals is to really combat plant blindness and to see that when you're looking at the woods, there's actually a huge amount of activity. There's this whole assemblage of organisms within any given forest. And when you're in Nevada County, we benefit by having areas that are, roughly about 1,000 feet in elevation in the oak woodlands, and you climb into the pine woodlands, and then you hit the granites and to the tip top of the Sierras and over on the east side where desert plants start showing up. And so you get this huge diversity of plants. Like we have a really special assemblage of plants in our area. We get the southernmost extent of the Pacific Northwest kind of Cascade associated plants. We get the northernmost extent of kind of the like deserty Mexican, Southern California plants. There's a whole bunch of stuff that's only grows along the coast, but because of the influence of the delta, we get some of those species here as well. And then owing to the different habitats and the elevation gradients, we just have, it's something like 2,000 species of native plants and something like 3,000 plants in total that are naturalized over here, if you count the non-native ones as well.
Wow. Okay. And do you have a presentation, a slideshow to take us through?
I do, yeah. And since we covered the what the Native Plant Society does, I'm going to breeze through my first couple slides here. So thank you all for tuning in. My name is Shane Hanofee, Vice President of Redbud Chapter, California Native Plant Society, and I'm going to be talking a little bit about how to identify a plant, what it entails truly to identify a plant and to call it by one of its many names. And then I'm going to tell a couple plant stories and hopefully get you really excited, as excited as I am about the plant life that we have in our county here.
Great.
And so, we covered this one already. Native Plant Society, it's a statewide organization, and, we want to conserve California native plants. And we do that through plant science and education and horticulture, because, growing horticulture is just the process of growing plants in a controlled setting rather than them existing in nature. And native plants act a little differently than most of the plants you'd grow in your garden. So sometimes they're easier, sometimes they're harder. And so the Native Plant Society wants to give you the best information so that you can kind of navigate how to grow these plants. And of course, we engage in community service activities, invasive species management, trash pickups, and then we do field trips and workshops and lectures as well as educational moments, and get you out in nature and get you really thinking about these things. And so the Redbud chapter, again, pretty much covered this one. But one of the things I do want to touch on is that we do support and distribute the very latest in plant science to inform the local community on how best to approach pressing issues of the day, including fire safety, invasive plant management, and climate change. And fire safety is on everybody's mind right now. And the truth of the matter is that fire was here before us. It'll be here after us, and it really doesn't care whether we're here or not. The vegetation and the ecosystem at large in our area is absolutely dependent on fire. If we suppress fire, then we have a diminished ecosystem. And the vegetation management policies are really at the forefront of how we approach those sorts of things. In the past, we did a lot of fire suppression, and we're sort of reaping what we've sown at this point with these mega fires. And certainly some of the solutions on the table are also, I'll use a strong term. They're a little bit pipe dreamy, but with these sound vegetational scientific principles, and we hope to influence some of the thinking and really actually protect us from fire, and also ensure that we have a healthy ecosystem at the same time. And invasive plant management, we're in a situation right now where all of the plants that are native to California have evolved here over the course of millions and millions of years. And not only have they evolved here, but they've co-evolved with other organisms that rely on those plants, whether we're talking about pollinators or fungi, or the animals which eat the plants, the birds which eat and nest in the plants. It's part of this larger system. And so when invasive species come in over the past 200 years, which is just a blink of the eye as far as evolutionary time goes, they can really wreak havoc because they haven't co-evolved with the organisms that are here. So if you have a native plant, it's kept in check by the fact that there are diseases, there are things eating it, there are things knocking it down. And when an invasive species comes in here, there's nothing eating it. There's no diseases. And so there's no checks and balances. And so these invasive plants just run amok. And they offer very little ecosystem services at the same time for the same reasons. We basically see some adaptable organisms, such as birds, for instance, utilize invasive plants. But beyond that, the suite of very specialized organisms are left without their host plants because the invasive plant has taken its place. And I'm going to get into some of these relationships a little bit in the future. And climate change, of course. Climate change definitely impacting plants, and we see it first in the plants. If the earth warms up and a bird cannot deal with it, the bird can fly away and it can migrate and it cannot return to the overheated areas. But plants do not move, they do not migrate. And so we basically see them dealing with the stressors induced by climate change. And we're seeing that played out in the fact that plants that used to grow solely in the valley are now moving up the hills. They're moving higher in elevation where it's a little bit cooler. And that whole shift is just moving up over the entire transect of the Sierra. And so the plants that are at 5,000 feet are climbing up to 7,000 feet and so on and so forth. And the problem with that is the plants that are at the tip top of the Sierras, there's nowhere else to climb and there's nowhere else to go. And so if climate change continues unabated, we're going to lose the plants which currently make up our alpine communities. And it's very concerning. And so we want to understand these things through the focus of vegetation. And a little bit happier note, we also plan on and put on fun activities to engage our members and the larger community in the appreciation of native plants, because it's one thing to just become aware of these things on your own, but it's a whole other thing when you can be part of a community and a whole bunch of people who are also concerned with these things and can offer guidance and different anecdotal evidence and different experiences. And it's just a wonderful community. I really do invite everyone to please become a member of the California Native Plant Society. And there's a whole bunch of benefits. All right, so now I'd like to talk a bit about how to identify a plant. I think this is something that a lot of people want to learn, and it is part of my job to be able to identify plants and to use the tools effectively and figure out what grows in a specific area. And so I'm going to talk about it in two different approaches. The first one, I'm going to talk about taking photos for identification, because I recognize that a huge amount of people are not necessarily interested in learning all of the botanical vernacular and really diving into the deep end of what it takes to positively identify a plant. Sometimes they just see a plant outside and they want to know what it is. And so I'm going to give you some of the tools that you can adapt so that you can take a photo of a plant and bring it to one of these resources, which I'll lay out in a bit. And the person who is identifying the plant for you will have the best chance at actually getting you to an actual ID, because it can be very difficult, believe me. All right, so the first thing, there's no such thing as too many photos. One photo focused on a flower, just top down with just the face of the flower, has very limited use unless that plant is really distinct and there's no other plants that look like it. You may think of a plant like a dandelion, and when you think of a dandelion, you're probably imagining these yellow flowers, which are made up of all these little strap-like petals radiating out from a center point. Well, I can tell you there are natives and non-natives, maybe like 150 different plants that all look like that. And if you just took a picture of those strap little petals, we wouldn't be able to tell you what plant you have. So leading into the next one, you really need to take photos of specific parts for each individual grouping of plants. And in lieu of if you don't know what specific parts you're supposed to include for a group of plant, I recommend include them all. So include a photo of the flower face down, the back of the flower, a side view, pictures of both sides of the leaves, the stems at the top, the stems at the bottom, any fruits or seeds you may find. Just if you can take as many pictures as possible, then we'll probably be able to derive a lot of information from those pictures and hopefully get you to a plant. The next part is very important, and you'd think it was common sense, but I can't tell you how many times I have been sent photos of plants to identify, and they are just blurry messes, like somebody has taken a photo going 60 miles an hour down the highway of a plant and wants me to tell them what it is. So please make sure your photos are in focus. If you're using a phone, you can tap the screen to make it in focus. You can hold your hand behind the plant to give a surface to focus on if it's a really thin, wiry, small plant. And then a lot of the phones, if you hold the screen, it'll lock the focus in place. And so you can just move the phone back and forth. So those are some tips in getting it in focus. Very important. And the next is close-ups and habitat shots. These are opposite ends of a spectrum. And the idea is that sometimes it's really important to get a really close-up shot of the plant. There might be little tiny details, such as the nature of the hairs on the plant, which tell the difference between two look-alike species. So like, for an example, one species might have hairs that are straight, and the other ones might have hairs that are laid down across the leaf, and a third species might have hairs that are all branched and woven together. And we wouldn't be able to tell the three apart without close-up shots. And the beauty is nowadays you can go and buy these little clip-on macro lenses, which I use extensively. And you clip it right on your phone, and you're able to take these really close-up photos, which encompass a lot of detail. It's really awesome that they offer these. And the other side of that spectrum is habitat shots. So it's a really beautiful photo usually to get it really close up and to kind of blur out the background when you're taking pictures of various plants. But you really want to take a step back, and you want to include a shot that shows the whole plant and how it's growing. And we want to see what kind of habitat is it growing in. Is it in a wet location? Is it in a dry woodland understory? Maybe we could even tell a lot about what's going on by the duff that's on the ground, whether it's in pine duff or oak duff. Can be really informative. We have two look-alike species of lilies, for instance, and one of the easiest way to tell them apart is it growing in a wet area, like on the side of a stream or a river or a creek, or is it growing in a dry area, like in a woodland understory? And that alone is usually enough to tell the two lookalikes apart. And the last part is location. So this is not something that's going to show up in your photos for the most part, but please do tell people where you found it. It doesn't have to be super specific. It can just be elevation and the county. That's usually good enough. If I know something was found at 6,000 feet in Nevada County, I can pretty much assume that it's going to be a granite associate. And so location is really important. You do want to be careful, because if you reveal too much of the location, especially over social media, you could invite people to go either like trample it, visit it too hard, or there's definitely the concern of poaching out there if you were to find a sensitive species. And we definitely do have problems with poaching in our area of our succulents and our orchids and all of these beautiful plants, which actually, once you take them out of their natural settings, they do not live very long. And so you've essentially just murdered the plant, and you will not be able to get it into cultivation. But that's another topic. The next I want to talk about, the path of due diligence is what I'm calling it. So this is what I do. This is what professional botanists do in order to identify a plant. And so this is if you want to do it for yourself. You don't want somebody else to tell you what this plant is. You want to read the literature. You want to go through all of the appropriate steps and know beyond a reasonable doubt what plant you have. And so the first step of that is consult keys. And by keys, these are resources. The one for California that is the best is included in this book called the Jepson Manual of Vegetation, of Vascular Vegetation, excuse me. And basically a key will give you two options, and you choose one of the two options, and then it brings you to the next node. It's like a flow chart, basically, for identifying plants. And so you might have like a key break which says like plant is hairy or plant is not hairy. And you look at your plant, and if it's hairy, you go on to the next one, and then it'll give you a new set until you finally arrive at a species. And this is what these are the most robust resources we have towards identifying plants. And they do, fair warning, use a lot of technical terms. So I recommend, if you want to get into this, to buy a botanical glossary, specifically an illustrated one if you can get it. And this will help define all of those terms. And as you're learning, you're going to be flipping through that glossary a whole bunch. But eventually, like with most things, practice makes perfect, and you start to just kind of absorb the information. The next, use a hand lens. This is to do with like the close-up shots. A lot of the details that you'll need to identify a plant are going to be too small for you to notice with your naked eye. And so a hand lens, around 10 to 20x magnification, is usually sufficient for getting most of the plants down to the level where you can see all the details that you need. Some other plants, such as like mosses and liverworts and a few others, actually require a microscope. But I understand that that's probably too much of an investment for most people. But a hand lens, you can get very far with just a hand lens. Secondly is use a ruler. And what I like to do is actually bring a ruler with me out in the field and take my photos of the plant with the ruler in the shop, and measure the different parts of the plant. A lot of plants, the difference between two lookalike species is the size of a specific part. So it might say, like, this species has flowers that are 11 to 25 millimeters across, and this species has flowers that are 30 to 45 millimeters across. And if you don't have the ruler, you can only kind of guess as to what measurement you have. I even have a friend who has a ruler tattooed on him for this. So he doesn't have to bring the ruler into the field anymore. You just get the tattoo. All right, the next tip is consult multiple sources. And that's because when you're just consulting one source, there is still the ability to make a mistake. There is no infallible resource. And part of the reason for that is, and this is going to lead into my next bullet point too, we are trying to rigidly define organisms which are not rigidly definable in most cases. Species exist on somewhat of a spectrum in a lot of cases. Of course, I'm generalizing here. And so there's such a thing as hybridism, where two different species actually reproduce and produce a plant where it has intermediate characteristics between the two you're looking at. And, without getting into the weeds on it, pun intended there, you can't expect a definitive identification in every case. Sometimes there's weird plants. A really good example of this is our oaks. Our oak species, it's what's called plastic. They interbreed a lot, and you get hybrids a lot. And not all of the hybrids have names even. And so you'll get a plant which has characteristics of multiple species. And the best you can do really as a botanist is say that it's a likely hybrid between species X and species Y, and maybe it'll show more traits of species X. And that's the best that you can do. And another thing about not expecting a definitive identification is sometimes the diagnostic part of a plant to identify it is the seed. And so if you're looking at a plant when it's still in flowers and it hasn't produced the seed yet, you're not going to be able to tell what plant that is definitively. You can make a guess maybe, but you won't know until you come back and look at the seeds. And so a lot of plant identification requires return visits and patience. So I really want to stress that, because we do really live in a time of sort of instant gratification. And, if you're just expecting an answer all the time, you're going to be a little disappointed. It doesn't exactly work like that. And of course, as time goes on and we get more people into botany and into studying plants, and we learn more about these organisms, it's going to get better and better. But there's, you wouldn't believe how much low-hanging fruit there is in plant sciences, and how little, or how much more there is to discover. All right, and the last part about identifying plants, here's just some resources that you can use to push it a little bit further, push yourself a little bit further, get a little better education at plant identification. Number one, the Redbud field guides. They helped me. I guarantee you, if you're local, they'll help you. Field guides are great, and they're super handy for bringing with you, and you can hike along with them. Just know that any field guide is limited. There's about probably 800 species in each book of the Redbud field guides. And like I said earlier, we have about 2,000 to 3,000 plants. So you have to make those choices. Which ones are you going to publish? And keep in mind too that once it's published, it's already out of date because there's constant research happening all of the time. So what you'll want to do is find something in the field guide that looks like it might be right, and then go do some research online, because the next two resources, calflora.org and the eJepson, are dynamic resources online that are kept up to date with all the latest naming conventions, all the latest new species. And so you just want to make sure that the plant that you're looking at in the field guide is still called the same name today. And a little digression about plant names. I really think it's important for people to engage in the scientific names of plants. That's the Latin binomial, where you have the genus and species. So like an example, humans are Homo sapiens, genus Homo, species sapiens. And that's because this is the international static, quote unquote, name for a given plant. And I put that in quotes because as we learn more about the plants, sometimes they do shuffle the names around. But the purpose of these names is to actually illuminate evolutionary relationships between plants, and it is not to make it easy to say, unfortunately. And you can feel a little bit more confident knowing that there is no true pronunciation of any of the Latin words. Latin was used specifically because it's a dead language, and it is not changing. And so you can pronounce these Latin names however you want, and nobody should give you any guff about it because they don't know. Nobody knows. The problems with the common names are often a certain plant will have multiple common names, and often multiple common names will apply to one specific plant. So I can't tell you how many arguments I've witnessed where people are arguing and saying, oh, it's this plant, and they'll say, no, it's not this plant. And it's because they are using different names for it, or they'll call it the same name, but they're talking about two different plants. It gets all confusing. If you use the scientific name, everyone will always know what plant you're talking about. All right, enough for that. A couple more resources. Flora of North America. It's North American wide. The other two are California only. So if you do use Flora of North America, it's very robust and it's very good, but you have to weed through a lot of plants to get to your answer. So as local as possible, it usually makes things easier. At the same time, Flora of North America, because it's so completist, is a really good source to turn to, especially if you start striking out with some of the local sources. iNaturalist is a wonderful website and app where you can upload photos of what you're seeing, and experts will come along and ID them for you. And then that data is aggregated and used by scientists all over the world. Can't recommend that one enough. It's helped me hugely in my process of learning about botany. And surprisingly, Facebook groups are pretty good for plant identification. You have a lot of experts who wait out in those Facebook groups for people to post plants, and certainly the apps that you can download in the App Store, which use image recognition software to identify your plants, are pretty amazing for how accurate they can be. But especially for native plants, they tend to be pretty poor. And that's because they're focused more on like garden plants and horticulture plants, and the plants that you see in the wild, they don't know how to make heads and tails of it. And when you think about it, I talked about these little microscopic differences between plants and needing multiple photos. How can an image recognition software really interpret all of that information? And that's why real people are still the best. And so the Facebook groups contain those real people. All right, so now I'm going to talk a little bit about some of the cool plants and plant phenomena that you can find in our area. Number one, you may have heard this term before, it's super blooms. And unfortunately this year, because of how little rain we had, we probably won't be having any super blooms. But this is a situation where the weather is just right and it causes these profuse bloomings of plants. On the left, you have the sky lupin, Lupinus nanus, and that picture was taken at Table Mountain. Table Mountain is good for some super blooms most years. It's a really spectacular wildflower display. And unfortunately, as is the case with most super blooms that make it out into sort of the public knowledge, it's a little bit on the decline because of how many people show up there. It's a little bit overcrowded, and people don't always just stay on the paths, and they do trample the flowers and they do pick them. So if you do visit any of these amazing botanical areas, tread lightly, practice leave no trace ethics, and then we can enjoy it for generations to come. And on the right, we have a beautiful Montaigne Meadow. So this area would be under snow for like 6 months plus out of the year. But then in that short growing season, there's a huge diversity of plants that just explode like fireworks into these meadows. And so you have things like paintbrush and cinquefoil and penstemon and yarrow, all intermingled, different colors, attracting different pollinators. Really beautiful sites. I love the Montaigne Meadows. All right, believe it or not, in Nevada County, we have carnivorous plants. These two specifically are the ones you're most likely to come across. However, they are both rare plants, so you're not that likely to come across them. They need really specialized habitats. On the left, we have Drosera rotundifolia. That is called the round-leaf sundew. And this picture really doesn't show the size of it. The full plant is about the size of my thumbnail or so. Very, very, very tiny plants. They can get bigger than that. They can get, about 5 inches in diameter or something. But this specific plant was quite small and fully grown. And so basically, these carnivorous plants, they grow in nutrient-poor areas. So there's not a lot of nutrients in the soil. And so over time, they've evolved the capacity to predate and attract insects and basically trap and kill the insects to sap some of their life force and give it to themselves. So the sundew has all of these stalks with a sticky glue on the surface, and an insect will touch that and struggle and will get covered with a lot more sticky glue, and eventually the leaf kind of folds in and the insect perishes and decomposes and provides nutrient to the sundew. And then on the right, we have Darlingtonia Californica. This is called the California pitcher plant or the cobra lily because it kind of does look like a cobra, at repose there. And this one is our only native pitcher plant. And I don't know if you can make it out, but underneath this hood, there's a little opening. And the insect will fly in the opening, and it will get lost in that lengthy tube there. And at the top of that plant are all of these clear windows, and you can kind of see the clear windows. They have like green veins bordering them. And if you've ever seen like a fly that gets stuck inside your house and it just bangs incessantly against the window, the same thing happens here. The fly thinks it can fly straight up, and it doesn't know that it has to actually go up and then down and then out to get out of this thing. And it will do so. It will bang against those windows for so long that it eventually tires itself out and tries to land on the side, but the side is really slippery, and so it falls down into the bottom of the pitcher plant where there's this really viscous liquid, and it will drown, and the plant will absorb the nutrients as it's decayed. Now, the thing about the pitcher plant is it's not actually the pitcher plant that's digesting the insects. It has a suite of microorganisms that live in the liquid down in there that actually do the digesting and then basically defecate, and that defecation is the nutrition for the plant. And so it actually works a lot like us and our gut microflora, where we have bacteria and all sorts of different things in our stomachs which digest or do a lot of the digestion for us. It's the same principle. All right, this is one of my favorite, well, really we're going to talk about two groups here, but these are some of my favorite plants. We're going to talk about parasitic plants and a group that are called Mycoheterotrophs. And I'll start by defining Mycoheterotrophs. Mycoheterotrophs are those plants which get all of their nutrition from tapping into fungi that live in the soil. And the cool thing about both of these plants is you'll notice the coloration here. There's almost no green happening. They don't have chlorophyll. If you think back to your 9th grade biology class, you need the green chlorophyll to take energy in from the sun and turn that into sugars and grow. These plants do not do that, except for one of them there that has a little bit of green and does a little bit of photosynthesizing. But the other ones don't do any photosynthesizing. They steal their nutrients from other organisms. So starting over on the right, we have one that I think a lot of people know about at the high elevations. We have the snow plant, bright red plant that's actually a member of the blueberry family. So this one is more closely related to, like, say, manzanita or your common garden blueberry than the other plants that I'm showing here. And this one is a mycoheterotroph, so it taps into fungi in the soil, and it's one of the reasons why it can grow in the deep, dark understory of the forest. It doesn't need sunlight, so it can colonize these very specific habitats because it doesn't need to compete for sunlight with other plants. So moving to the right on the top, we have a plant called Particularis densiflora. It's the Indian warrior. This is a parasitic plant. So this one actually taps in with specialized roots that are called historia. It taps into the roots of other plants and steals a little bit of nutrients from them, enough to survive. And this one will typically parasitize manzanitas or toyon Very interesting plant. Moving, well, let's just go clockwise here. So at the top here, we have a plant which has a very apt common name. So common names aren't all bad, because this one's called elephant's head, because it does look like an elephant with the two little ears here and the big trunk. This one is in the same genus as the one we just talked about. This is Particularis Agrolandica, and it grows in high elevation meadows, and it's also a parasitic plant, but it typically parasitizes herbs and things that are found in wet meadows. And the same for the plant that is to its right on the top. That's Lemon's paintbrush, a beautiful purple paintbrush, also high elevation meadows, also parasitizing the meadow herbaceous layer, not so much the trees and shrubs. And below that is a gorgeous plant that almost looks fake. Every time I see this one, I'm just absolutely blown away. You don't come across it too often. It's called the sugar stick. It's Allotropa virgata. And it kind of has this barber pole look to it with the red and white stripes. This one's also in the blueberry family, and it's also a mycoheterotroph. And you might be tickled to find out that this actually associates with the matsutake fungi, which is a choice edible fungi. So if you see this plant, you can come back in the winter and there will be matsutake there, or at least its mycelium is living beneath the soil. So sometimes plants and mushrooms can kind of indicate for each other, which I think is pretty neat. Going to the left now with this little golden plant right here, once again, no green, and this one's growing right out of the branch of a pine tree. This is our dwarf pine mistletoe, and mistletoes also have hystoria, and they tend to grow above ground, so they're not tapping into the roots, they're tapping into the vascular system of the plant, of the host tree. And this one specifically grows on conifers. We have a different species that grows on oaks, and they're really neat because when they do produce flowers and they make fruit, the fruit explode with propulsive force, and the seeds go flying, and the seeds have this sticky little mass on them. And so the seed will then land either on a new branch or land on like an animal, and the animal will drop it off somewhere, and where it can germinate, it'll grow new roots and penetrate into the host plant. And I should mention, while I'm talking about parasitic plants, there's a strong evolutionary disadvantage to killing your host, because if you kill your host, there will be no more host for you to live on. So most of these parasitic plants, and mistletoe included, do not negatively impact the host that they're on beyond a very, very small amount. I know there's a pervasive myth about the need to remove mistletoe from oak trees, say. Absolutely a myth. There's no need to do it. The mistletoes are wonderful bird food. They nest in them. They're native plants. They don't cause any problems to the tree, and you can't really remove it. It's going to take you multiple years to attempt to remove one instance of it, but if you have a tree that's laden in mistletoe, these are individual plants, and you have to remove each single one. And if you have a tree, once again, laden with mistletoe, it's more a sign that birds love to sit in that tree, because the birds will transport the seeds. And as soon as you've removed it from every bit of your oak tree, a bird's just going to land there and poop out another mistletoe seed, and it's going to start an infestation over again. So you're sort of fighting a losing battle, and there's no harm that comes of them. So just enjoy the mistletoe, folks. That's my message there. All right. Then the final one, we have a little plant. It's Ephylon Corbosum. It grows. It's a very small plant. That whole plant is maybe like an inch tall. And it grows in high elevation, like alpine settings. You can see all this like alpine rock below it. And this one is another parasitic plant that taps into the roots of like sagebrush, so like our artemisias that grow up there. And it's absolutely gorgeous and has no chlorophyll. All right, vernal pools. Vernal pools are stunningly amazing, and unfortunately, they're disappearing from our landscape. At one point, this was one of the dominant habitats over the Central Valley, and at this point, we've lost something like 95% of the vernal pool habitat because it's been converted into urban sprawl and farmland and just developed out of existence. If the actual vernal pools haven't been bulldozed over, then the altered hydrology has eliminated them. Because let me step back and define what a vernal pool is. It's essentially these seasonal wetlands. It's a depression in the landscape, and at the bottom of the depression is a hard pan soil. And so the rains come and they fill up these depressions, and then because of the hard pan, the water really just lingers there until it evaporates out in the hot summer. And you will get these rings of plants that grow as the water recedes. And so the different species of plants like different amounts of moisture, and so you get these concentric rings of wildflowers vernal pools are home to so many rare species, and to be honest, they probably weren't rare until we got here. If you lose so much of your habitat, then you're probably going to end up being a rare plant. And there's a very little vernal pool habitat left in Nevada County, and they can occur technically at all elevations. So you do get high elevation vernal pools also, but they're a lot more common at the lower elevations. So it tends to be the last vernal pools remaining at the low elevations in our area. You have to go to Placer County to see. There's nothing left pretty much at the lower elevations of Nevada County. Maybe a few here and there, but certainly not as many as there used to be. Okay, orchids. I think a lot of people think of orchids as tropical plants, or like that thing that you buy at the grocery store checkout and put in your office, and it's really hard to keep alive. But we have a lot of native orchid species. Orchids as a family, it's the Orchidaceae, is I think it might be the most specious family in the world. So there are more species of orchids than any other family of plants. And likewise, we have a ton of them here, and they're some of the most beautiful plants that you'll see. And I won't go through all of them. I'll just touch on briefly. We have two species of lady slipper, both all the way to the left and at the upper right. The one at the upper right is one of my favorite flowers in the entire area because of the twisting lateral petals here that spiral down. And they're called lady slippers because of this lower pouch right here, which is an inflated petal. And the pollinators climb down inside that pouch, and they have these specialized pollen dispersal. It's called a pollinia. It's basically a sac of aggregated pollen, and there's a little trigger, and the insect brushes the trigger, and the trigger deposits the pollinia on the back of the pollinator, and the pollinator flies off and visits another orchid and deposits the pollinia there. And really, really fascinating pollination strategies there. The one right here over to the right of the clustered lady slipper is this one right here, is called Lady's Tresses, and it's in the genus Spiranthes. And these are really recognizable because though they have relatively small little orchid flowers, they are geometrically gorgeous. And the flowers kind of spiral up the entire inflorescence here. Really love those. They're a plant of meadows. This red one is called the spotted coral root. This one is a plant of the woodlands, and it's in the genus Corallariza, which just basically means coral root, which is why we call it coral root. And it has this spotted lower lip here. This is probably one of our more common orchids, and take a little closer look next time you're in the woods. You might see this guy right here. And finally, we have the phantom orchid, named for its ghostly white appearance, absolutely lacking any sort of coloration besides a little bit of yellow in the flowers, and really amazing orchid that also is in the pine woodlands. And I should mention that orchids are also, every orchid is a mycoheterotroph. So these are plants which get their nutrition from fungi in the soil. When they produce seed, the seeds are dust-like. You wouldn't be able to hold one in your hand. You would lose it. They're incredibly small. And when they land in an appropriate area with the fungi that they have co-evolved with, that's when the orchid germinates. And so if you were to collect the seed from any of these plants, and plant it in your garden, it's not going to come up. If you were to collect the seed and put it in a controlled laboratory greenhouse, it's not going to come up. You need to introduce the fungi that it's associated with. And so this is one of the reasons why habitat protection is so important, because this is not something that you can restore. These are not plants that you can replenish. You can't grow them somewhere and then plant them out where they used to be. Once they're extirpated from an area, they're gone forever. And certainly, especially the lady slippers, and especially the phantom orchid, are kind of disappearing from our landscapes because people think they can take them home. All right, big trees. I think most people are probably familiar with both of these species. California is home to some of the largest trees on the face of the earth. And on the right, we have two pictures of the giant sequoia. And the giant sequoia are native to the Sierras. So the only place you'll find them in the world is in the Sierra Mountains. The northernmost grove is actually in Placer County, but it's not a bad drive to go see them. I highly recommend, if you've never been in a sequoia grove, it's absolutely magical. It's intense to be around such large beings and to know how ancient they are. I highly recommend it. On the right side, these are the coast redwoods. And so the redwoods and the sequoia are two different species, though they are in the same family. They are in different genera. Genera is just the plural of genus. And the coast redwoods exclusively grow on the coast. And so you have these geographical separation between the two species. Although I should mention, because both can be planted elsewhere, we do have redwoods out here planted in people's yards. They do have sequoias planted near the coast. And you do get sequoias planted up here in Nevada County, where they will probably never grow as big as they do in Placer down to like Tuolumne and further south. But yeah, we're super, super lucky because these are plants that people come from worldwide to be in. There's nothing like the conifer forests of California. All right, and the last group I'm going to talk about are our ancient plants. And now neither of these two species occur in our area, but I just wanted to highlight them because I think this is something that people might not be aware of. Like, we have had humans here for about, I don't know, 10,000 years or so. And then the Spanish came over about 500 years ago, and the Europeans about 200 years ago. What you're looking at are two plants that are thousands and thousands of years old. So these individual plants have been here for multiples amount of time since the gold rush started, since all of our technological advances. The single plant, each of these plants was alive when Jesus was alive, for instance. It's pretty incredible to think about it. So the one we're going to start on the right. This is the one that I think people will be most familiar with. It's called the Bristlecone Pine. And it grows at the very high elevations of the White and Inyo Mountains in Southern California. And what we're looking at right here is the oldest bristlecone pine known. Its name is Methuselah, and it's about 5,000 years old. And it can live so long because it looks like it's dead, right? But there's a little bit of some leaves over here. When a branch has sort of outlived its usefulness, it just lets that branch die and then grows a new branch. And so the root system has been around for about 5,000 years, which is just absolutely incredible. And then on the left side, what you're seeing right here, this ring of vegetation, this is a single plant. This is called the king clone creosote bush. It is a clonal organism, which basically means that at one point there was one plant in the center here, and it has just grown and grown and grown until now it's this big ring, and the center has just died out. But this is still all the same plant. One plant, genetics taken from a plant on the foreground is the same genetics as a plant taken from the background. This plant, believe it or not, is 11,700 years old. It's just absolutely mind-boggling, and it looks so non-assuming. I mean, it just looks like you're looking at a desert scrubscape. Like there's nothing substantial, but you're looking at something that existed before agriculture. Humans weren't farming when this plant was germinating. And it's just absolutely mind-blowing, and it's really inspiring to think of, the effect that we have on plants is such a small portion of the overall evolutionary history of these things, that as bad as it seems that it's gotten for the plants and for the environment, we can turn this thing around, and we can really look at the environment through a renewed lens and this sort of larger reverence and really do good in the world. And so with that, that'll be the end of my presentation. Got a nice little meme there for you. And, I invite you, please send me an email if you want to chat. I'm always happy to get plant pictures or talk about native plants. And then here's some of the social media you can find the Redbud chapter at. We're on Instagram. You can go to our YouTube channel. We have a bunch of lectures up there. I've been doing these virtual hikes lately on there, where so you can come along with me on the trail, and I dispense a whole bunch of rambly plant knowledge like I just did. And there's some good stuff on our YouTube, and we're always adding stuff, so go check it out. We're on Facebook. We also have a forum on Facebook that you can join, and the forum, you can post pictures of plants you want ID. There's a whole bunch of experts out there who can give you really good advice. You can learn how to garden with native plants, really just talk about any native plant topic you want. And please check out our website. We've got a lot of resources up on our website, and you can find it at the address on your screen. And so with that, thank you so much.
Okay, great, Shane. Thank you. Good thing we didn't get into the weeds, huh? No, seriously. there's so many questions I could ask. There's so many directions we could go with this, but the truth is we're already out of time. And that was a fascinating presentation. Thank you. I encourage everybody to use those resources, to contact Shane if this is your cup of tea. It seems like you've got a lot of knowledge to share. And
oh yeah, I mean, I could have doubled that easily. So, yeah. Never want me back.
Okay, great. Yeah, I mean, I'd like to talk about Scotch broom, but we'll save that for the next time. Okay.
Oh, yeah. That'll be a half an hour in and of itself.
Yeah. So that's Shane Hanofee of the California Native Plant Society. And let me tell you, next week we will be talking with Robert X. Trent about Nevada County's future strategic small business roles in the local economy. The conversation will dive into how we can gracefully transition away from necessity, entrepreneurship, and extractive business practices and envision what our community will look like when we have more future-forward companies supporting the happiness, well-being, and livelihood of our residents. Again, I'm Jake Freydont-Attie. This has been In Conversation With. Thank you, Shane, very much. Thank you to everybody else who makes this happen, especially Conrad and Amber Jo and Cameron and everybody else at the Center for the Arts. I'll see you next week. Thank you.